Tesla just changed everything again. At a recent live demo, Elon Musk's Optimus humanoid robot stunned the world by moving in real time, reacting fluidly, and even dancing on stage without pre-programmed instructions. But the real breakthrough: Optimus is now capable of zero-hour training, meaning it can watch a task in simulation and immediately perform it in the real world without ever needing physical practice. This isn't just about choreography. We're talking autonomous behavior, self-arming, and human-like coordination, all powered by Tesla's full-stack AI. In this video, we'll break down exactly how Tesla's Optimus learned to dance, navigate complex tasks, and why this could mark the beginning of a future where humanoid robots work alongside us, or maybe even replace us. Let's dive in. Tesla's Optimus robot just demonstrated something that most humanoid robots still struggle with: fluid, real-time movement. During its latest showcase, Optimus appeared on stage and performed a full dance routine, not with jerky, pre-programmed motions, but with natural synchronized motion that looked remarkably human. This wasn't just for show. What made the demo so impressive was that it took place in real time. No fast-forwarded edits or computer-generated overlays. Optimus responded live, shifting its balance, adjusting its limbs, and maintaining coordination throughout the performance. For a bipedal machine with the same basic structure as a human, this level of physical control is a major milestone. Tesla has been refining Optimus using the same neural networks and vision systems it uses for autonomous driving, which means the robot is learning how to navigate the world through cameras and AI, not scripted code. It sees, predicts, and responds, all on the fly. The robot's design has also evolved. Compared to earlier prototypes, the latest version appears slimmer, faster, and far more agile. It's a clear signal that Tesla isn't just building a humanoid for headlines. They're serious about making a robot that can work, adapt, and eventually live alongside humans in real environments. One of the most groundbreaking advancements in Tesla's Optimus project is the integration of zero-hour simulation to reality transfer. This isn't just a buzzword, it's a game-changer in robotics. Instead of teaching the robot through manual repetition or labor-intensive programming, Tesla enables Optimus to observe actions in a digital environment and immediately replicate them in the physical world using Tesla's in-house simtorial training pipeline. Optimus is placed inside a fully simulated workspace where it watches modeled tasks like object manipulation, placement, or sorting. It then translates this learned behavior directly into the real world without any need for physical trial runs. This leap dramatically reduces the time and complexity needed to teach robots functional skills. For example, the robot was shown completing a simple sorting task in simulation, picking up colored objects and organizing them by type. Then, without any further tuning, the actual hardware executed the same job in the real world with smooth precision. This showcases how Tesla's advanced neural network architecture generalizes learning from virtual spaces to live environments. Even more impressive is that this learning loop requires minimal human supervision. Once a skill is embedded through simulation, Optimus performs autonomously, navigating variables like lighting, depth, and placement without rigid parameters. This method not only scales rapidly, but positions Tesla as a leader in autonomous humanoid development. With zero-shot simtorial capabilities, the robot can train on thousands of scenarios daily, far outpacing traditional methods that rely on repetitive hardware testing. This isn't theoretical anymore. Tesla's robot is watching, learning, and adapting faster than any human instructor could teach it. Tesla's Optimus isn't just a performer. It's engineered for task-level autonomy. Beyond fluid movement and advanced training protocols, the robot now incorporates self-calibration processes that allow it to continuously refine its motion, balance, and awareness of surroundings without external input. This progression enables Optimus to operate across diverse environments. Whether navigating a workspace, interacting with tools, or identifying targets, the robot updates its spatial understanding in real time. What this means, in practice, is remarkable. The machine no longer needs pre-mapped zones or human-guided corrections. It self-adjusts, corrects alignment, and optimizes posture dynamically, much like a human naturally reacts to terrain or object weight. Its sensor suite, including vision-based perception systems, feeds high-resolution data into Tesla's neural engine. Combined with haptic feedback and biomechanical awareness, the robot can now determine object size, weight, and placement by feeling its interaction, not just by seeing it. This tactile layer allows for greater finesse and manipulation, such as handling delicate or irregular items. Even charging is hands-off. Tesla demonstrated that Optimus can locate and connect to a charging dock independently, showing awareness of energy levels and the initiative to seek power when needed. This step toward full-loop autonomy is vital. It eliminates dependence on humans for maintenance or downtime recovery. But Optimus isn't just about flexibility or automation. Elon Musk emphasized its future utility in roles like manufacturing, logistics, caregiving, and general-purpose assistance. Tesla's goal isn't novelty. It's a scalable deployment. Optimus is being developed to eventually carry out repetitive, physically demanding, or hazardous tasks, freeing people from those roles. What separates this project from traditional robotics is the unified AI backbone. Tesla's real-world driving data, simulation training tools, and humanoid engineering are all merged into a single architecture, giving the robot the benefit of lessons learned from millions of autonomous miles. The big picture: Optimus isn't just evolving, it's preparing for real work. And with each update, it's looking more like a machine that can function reliably in homes, factories, or even disaster zones, wherever intelligent human-like action is needed. Tesla's Optimus isn't just a prototype anymore. It's a functioning, learning, and adapting machine. What we've seen in this latest reveal marks a major shift in robotics history. Real-time motion, simulation-trained tasks, autonomous navigation, and even self-charging, all powered by a unified AI infrastructure that draws from Tesla's autonomous driving experience. What's most remarkable is that all of this is happening now, not in some distant future. Optimus can already observe, interpret, and act in the real world without hard-coded instructions. It's evolving like a digital mind inside a mechanical body, learning faster than traditional robots and correcting itself without supervision. This isn't about replacing humans, it's about augmenting capability. Imagine workplaces where robots handle repetitive, physically demanding jobs while people focus on strategy and creativity, or homes where intelligent machines assist the elderly, help with tasks, or even provide companionship. Elon Musk and Tesla have long promised that Optimus would become the most valuable product the company ever builds, and now we're seeing exactly why. Each public demo moves it closer to commercial reality, a future where general-purpose humanoid robots are not just possible, but practical. So what do you think? Is the world ready for AI-powered robots that learn like we do? Let us know in the comments. And if you want more updates on AI, robotics, and Tesla's next big leap, be sure to like, subscribe, and hit that bell. Because the robot revolution, it's no longer science fiction. It's here.